All right, folks, get ready because today we're diving deep, really deep into some pretty mind-bending stuff.
You would say that there?
The origins of the universe, the ultimate mystery.
And we're tackling it head on.
We had a listener write in asking all about this quantum foam and, well, how it all connects to how the universe even began.
Ah, yes, quantum foam.
So we've got a bunch of research here, articles, interviews with physicists, some pretty wild theories about reality itself.
Definitely some heady stuff.
But don't worry, we'll break it down for you. We even found some analogies that, well, hopefully help make sense of it all.
Analogies are always helpful with quantum physics.
Right. Okay, so first things first, what in the world is quantum foam?
So picture this. You're zooming in way beyond atoms to a scale that's like impossibly small.
Smaller than atoms. Okay, I'm trying to wrap my head around that.
And at that level, it's not this smooth, still space we imagine. Nope, it's bubbling, it's fluctuating, just this constant chaotic sea of energy.
A chaotic, huh? So not exactly a calm pond.
More like a raging ocean, but a teeny tiny one. And it, just like, when you look at the surface of the ocean, it looks all choppy and random. But beneath it, you've got all these complex waves interacting.
So that's what quantum foam is, like a wild wave party at the smallest scale imaginable.
Yeah, it's incredibly dynamic and ever-changing. It's a wild landscape down there.
Okay, but how small are we talking exactly? Like how small is this tiny scale?
We're talking about something called the Planck length. It's about 10 to the power of -35 meters.
Whoa, okay, my brain just did a backflip.
It's mind-boggling. I know, even an atom is huge, absolutely gigantic compared to the Planck length.
So if an atom was like the size of the entire observable universe,
then the Planck length would be like the size of a tree.
Whoa, okay, I'm starting to get a sense of scale here. But here's where I get really tripped up. This quantum foam, it's not just some before picture of the universe, right? Like it's not just something that existed before the Big Bang and then poof, the universe happened.
You're hitting on a really important point. A lot of these sources are actually challenging that traditional Big Bang singularity idea.
They are. So maybe it's not like everything started from a single, tiny, infinitely dense point.
What if the foam itself is the very fabric of reality? What if it's not a before picture, but the canvas itself?
So it's not a prequel. It is the universe. Mind blown.
Exactly. The universe isn't built upon it. It is the foam, fluctuating and evolving all the time.
It's not just tucked away in the past. It's happening right now, everywhere, even here.
Yeah, even as we sit here, our reality is essentially this sea of fluctuating energy.
Okay, I'm following so far. But here's the thing. If it's this chaotic sea of energy, how does it create the structured universe we see, like stars, galaxies, even us? How do we get from foam to, stuff?
So remember how we talked about those wave interactions beneath the surface?
The ones in that tiny ocean?
Right. Well, within the foam, these waves are constantly bumping into each other, interfering with each other. Sometimes they amplify, sometimes they cancel each other out.
Sort of like sound waves. Like two waves can combine to make a louder sound, or they can cancel each other out and, create silence.
Perfect analogy. So in the foam, when the waves come together just right, you get something called constructive interference, and that concentrates the energy.
Concentrated energy, like packing a punch.
And that concentrated energy becomes a particle-like excitation.
So that's how a particle is born. It's like a little burst of energy from those waves colliding.
Precisely. And on the flip side, when waves cancel each other out, that's called destructive interference.
Okay, I'm with you.
And that creates regions of low energy, which contributes to the spaces between particles, what we often call the vacuum.
So it's like a cosmic dance, a push and pull of energy.
Exactly. The universe isn't made of static blocks. It's this constant dynamic interplay of energy.
It's mind-blowing, really. But, particles aren't all the same, right? We've got protons, neutrons, electrons, all with their own quirks. So how does the foam create all these different types of particles?
Well, that's where the concept of charges comes in. Let's take protons, for example.
Positively charged.
Got it. So, a proton can be thought of as a region where those positive energy waves are really dominant, where all that constructive interference is winning out.
So it's like the peak of a wave, all that energy bunched up together.
Now, a neutron, on the other hand, it's all about balance. It's a point where the positive and negative energy waves cancel each other out perfectly.
So it's like the calm spot in the middle of all the chaos.
Exactly. It's a sort of equilibrium.
Okay, so protons are like the peaks, the bursts of energy, and neutrons are like the calm points where everything balances out. This makes me think about that whole duality thing we talked about earlier.
Oh, how so?
Well, we've got positive and negative charges, constructive and destructive interference. It seems like this balance, this duality, is everywhere we look in the foam.
You're right, it keeps popping up in these sources, and it might be even more fundamental than we realize.
Do you think so?
Maybe duality isn't just about opposites, but two sides of the same coin, like essential to how reality functions at its most basic level. You see it in the foam, in energy, in charges, even the way particles are created and destroyed.
Wow, it makes you wonder if this duality thing, this balance, is kind of the driving force behind the whole universe. Not just a feature, but the engine itself.
That's a really interesting thought, and one physicists are still trying to figure out. But it does seem like this idea of duality plays a key role in more than just particles. It might even help us understand the very forces that govern the universe.
Right, so we've got this quantum foam, this wild sea of energy, and it's creating particles.
Mm.
But what about the forces that govern those particles? Like gravity, electromagnetism, the strong and weak forces. Where do they fit into all of this?
That's where things get really, really interesting. The research you've brought suggests that those forces, the ones we consider so fundamental, might actually just emerge from the foam itself.
Wait, hold on. Are you saying gravity, something we experience every single day, might not even be a fundamental force? Like, it's just a side effect of this quantum foam?
That's exactly what some physicists are proposing. They think gravity might not be a separate force, but a consequence of how the foam behaves.
Okay, I need a little more than that. How can these tiny fluctuations create something as powerful as gravity, which literally shapes the universe?
Well, remember constructive interference, how those waves combine and create particles.
Yeah, like those little bursts of energy.
Now imagine tons of those particles all bunched up together in one spot in the foam. All that energy start to warp the fabric of space-time around it.
So like if you put a bowling ball on a trampoline.
Exactly.
Yeah.
The ball makes a dip, and anything else on the trampoline rolls towards it.
And that's gravity. Like other particles are drawn to these energy-dense spots in the foam.
You got it. That's how we experience gravity, not as a separate force pulling things together, but as a result of how energy is spread out within the foam.
Okay, that is pretty mind-blowing. So essentially, gravity is just a side effect, a consequence of all that activity in the foam.
It's a fascinating way to look at it, isn't it?
It is. But what about the other forces? Electromagnetism, strong force, weak force. Are those also just products of the foam too?
There are theories about that, too. Take electromagnetism, for instance. It controls how charged particles interact, right?
Right.
While some physicists think electromagnetism could be explained by waves moving through the foam, think about those ripples that spread out when you drop something in a pond.
I can picture it.
Those ripples could be like the electromagnetic force, kind of mediating how those particles interact over distances.
So it's like the whole universe is a giant pond, and the foam is making all these ripples that we experience as forces.
A great way to visualize it.
Yeah.
We might not be dealing with separate, independent forces at all. What we see might just be different ways that the quantum foam behaves, different sides of the same coin, you could say.
This is making me see the universe in a whole new way. It's like we're peeking behind the curtain and seeing the machinery that makes it all work.
And it gets even more incredible when you think about what this means for creation itself.
Oh, yeah. We were talking about that earlier. If the foam is everywhere, then creation isn't just a one-time Big Bang event. It's still happening, right?
Exactly. If the quantum foam is the fabric of reality and it's always fluctuating, then creation is possible anywhere, anytime.
You mean like new particles,
Right.
brand new matter just popping into existence all the time because of the foam?
It's a possibility that some physicists are really excited about. All those fluctuations could lead to new particles spontaneously appearing. Maybe even kinds of matter we haven't even discovered yet.
That's wild. So the universe is still under construction, constantly evolving and creating new things.
And that ties into the expansion of the universe, too. You know how scientists talk about galaxies moving farther and farther apart?
Yeah, like the universe is getting bigger all the time.
Well, what if it's not just the galaxies moving, but space itself being stretched because of how dynamic the foam is?
Oh, wow. Like the foam is the yeast in cosmic dough, making the whole universe rise and expand.
A great image. And it really speaks to how connected everything is in the universe. From the tiniest particles to the biggest structures, it all comes back to this one thing, this quantum foam.
Makes you wonder what else we might discover hiding within those tiny fluctuations.
Speaking of hidden wonders, there's another theme we keep bumping into in all this research, and it goes back to that idea of duality we talked about
Oh
before.
yeah, that everything has its opposite.
Yep.
And those opposites might be more intertwined than we realize.
Exactly. These sources highlight how duality seems to be woven into the universe at every level. You see it with particles and antiparticles, positive and negative charges, even the way those waves interfere in the foam. The big question is this duality just a random coincidence, or is it something more fundamental, a basic principle of how reality works?
That's a huge question. I mean, if duality is baked into the very fabric of the universe, that changes how we understand everything.
It makes you question everything about reality, about consciousness, even our place in the universe. And that leads to a final thought I want to leave you with.
Okay, lay it on me. What's this final thought about duality and where we fit in the universe?
Well, if the universe really is this giant interconnected web of waves, this constantly fluctuating quantum foam, you have to wonder about our own existence, like are WE just part of this grand cosmic dance of energy too?
So we might be even more connected to the universe than we thought, even down at the quantum level.
Think about it. We're made of the same fundamental stuff as stars and galaxies, those particles that pop out of the foam. But if you could zoom in close enough down to the level of that foam, are we really all that different from those waves?
Are you saying? We're like patterns in the foam, our thoughts, our feelings, our whole existence. It's all just a super complex interaction of those quantum waves.
It's a mind-blowing concept, right? And it really makes you question what we believe about ourselves, about consciousness, about the very nature of reality. What does it even mean to be human if we're ultimately just like a pattern in the quantum foam?
Whoa, it's almost like the universe is thinking through us, expressing itself through these incredibly complex patterns that we call human beings.
And if that's true, it opens up this whole new way of looking at our relationship with the universe. Maybe we're not separate from it at all, but an essential part of how it evolves and changes.
Wow, that's a lot to unpack. So try to sum up what we've learned today. We started with quantum foam, this sea of fluctuating energy that could be the foundation of reality itself. From that foam, particles are born, forces come into being, and the universe keeps expanding. And we might be far more intertwined with that quantum world than we ever imagined. Did I get that right?
You nailed it. And the thing is, we're really just scratching the surface here. Quantum foam is still this huge mystery, and physicists are coming up with new ideas and new implications all the time.
That's what makes it so exciting, right? We're on the verge of a whole new understanding of the universe.
Mm.
Who knows what else is hiding in those tiny fluctuations?
Absolutely. And if this deep dive has sparked your curiosity, I encourage you to check out those sources we used. We'll be sure to link them in the show notes.
And if you have more questions, please don't hesitate to ask. We love exploring these big cosmic mysteries with you.
After all, that's what the deep dive is all about.
So keep exploring, keep questioning, and keep looking up at the stars, folks. You never know what wonders you might find.